afternoon and welcome back to Maths by Gary Maths Tutorials. Today we're going to take a look at the inverse and identity of a 2x2 matrix. So we're going to find out how to calculate the inverse of a matrix. So matrix A, the inverse of matrix A would be A to the minus 1, and that equals 1 divided by A times D minus B times C, and then multiplied by D minus B minus C and A. So normally you would label a matrix A equals A, B, C and D, but when we're finding out the inverse of a matrix, it's A to the minus 1, so it's 1 divided by the determinant, and then we change the labelling. So first of all, D and A will switch places, so D and A switch places, so D becomes A and A becomes D, so they just switch round, and then C and B will become negative. So if B was, for instance, 1, it now becomes minus 1. If C was minus 1, it now becomes positive 1. So this is how we work out the inverse of a matrix. And we're going to also do the identity of a matrix. Now the identity of a 2x2 matrix is denoted by I, and it's 1, 0, 0, 1. And the way we find I is the inverse of a matrix, A to the minus 1 times the original matrix A, and that should get us I. So knowing this rule, knowing that A to the minus 1 times A gets us I, which is 1, 0, 0, 1, we can know for sure that when we work out the inverse, it's correct, because if we multiply the inverse by the original matrix A, we should get the identity 1, 0, 0, 1. So we'll go straight into an example, and I'll just write out matrix A. So we'll take A to be 6, 3, 5 and 2. And again, what we want to do is we want to work out A to the minus 1. So we want the inverse of this matrix. So we take 1 divided by A, D minus B, C, and that's all multiplied by the new labelling of the matrix. So it's D, A, minus B and minus C. So what we have to do is from matrix A, plug in these details, and it'll give us the inverse, which will be a number. So 1 over AD minus BC, that will take us to 1 divided by AD, 6 times 2, 6 times 2, remember minus, everything's minus by B times C, so 3 times 5. So let's extend that out, that gives us 1 divided by 12 minus 15, which just works out to minus 1/3. So minus 1/3 is now going to multiply the DA minus B minus C. So we switch places first of all, so D becomes A becomes D, so minus 1/3 times 2 and 6, so put them in first of all because they change, and then the negative, so it's positive 3, positive 5, simply becomes minus 3 and minus 5, and then we just multiply across to give us 2 times minus 1 over 3, which gets us minus 2 over 3. Minus 1 over 3 times minus 3 gives us positive 1. Minus 1 over 3 times minus 5 over 3 will give us positive 5 over 3. Minus 1/3 times 6 will give us minus 2. And that's us already worked out A to the minus 1. So the inverse of matrix A is minus 2 over 3, 1, 5 over 3 and minus 2. So again, as I said previously, we can prove that this is correct by knowing that A to the minus 1 times original matrix A will give us I. So it's a 2x2 matrix, so I will take the form of 1, 0, 0, 1. So we want to prove that this in fact is true. So A to the minus 1, we have minus 2 over 3, 1, 5 over 3 and minus 2. So this is all going to multiply by original matrix A, which if you remember was 6, 3, 5, and 2. So all we're going to do is multiply matrix a to the minus 1 by original matrix. So the inverse is going to multiply the original, and we want to show that it equals 1, 0, 0, 1. So we'll just start minus 2 over 3 times 6 plus 1 times 5, and then minus 2 over 3 times 3 plus 1 times 2, and then 5 over 3 times 6 plus minus 2 times 5, and then 5 over 3 times 3 plus minus 2 times 2. So I didn't spend that much time showing you how to do multiplication because I have that in one of my other videos. So if you want, you can have a look at that. But this will work out as minus 4 plus 5, minus 2 plus 2, 10 minus 10, and 5 minus 4. So minus 4 plus 5 gives us positive 1, minus 2 plus positive 2 is 0, 10 minus 10 is 0, and 5 minus 4 is 1. So as we wanted, we now have the identity. So we know that the inverse multiplied by the original matrix A gives us identity matrix 1, 0, 0, 1. So feel free to like this video and you can subscribe. And if you want, you can follow us on Twitter at Maths by Gary. And I hope you've enjoyed the video. Thank you.